Welcome to this explainer. Go ahead and settle in, because today we're undertaking a true forensic examination of the cosmos. We are opening a file on one of the most profound, stubborn mysteries human science has ever encountered. Welcome back to the GEM Files. This is case number 04 from the Vault of Broken Physics. Dark matter, the missing mass that absolutely refuses to be found. Today, we're going to look at the universe not just as it appears to our eyes, but as it behaves, and we'll explore the agonizing, massive gap between those two realities. Let's just start with the cold, hard facts. Galaxies rotate too fast. Clusters bend too much light. The universe behaves as if invisible mass is literally everywhere. You know standard Newtonian physics, the further you get from the dense, heavy center of a spinning system, the slower things are supposed to orbit. But when we actually look out at our universe, that localized rule just breaks down. Galaxies are rotating way too rapidly on their outer edges. Massive galaxy clusters are warping far too much space. The cosmos operates as if a colossal amount of invisible mass is hiding out there, pulling the strings of reality. So, mainstream physics gave this missing gravity a really convenient name: dark matter. But after 5 decades of exhaustive, multi-billion-dollar searching, the hypothetical particle that's supposed to make up all this matter flatly refuses to appear. Take a second to let the immense scale of that mystery sink in. The stars are moving as if something is there, but what is there refuses to be seen. Now, what's really interesting about this slide is that modern physics didn't just casually invent dark matter to patch up a minor math error. It's not a placeholder born of lazy observation. The evidence for missing gravitational influence is absolutely overwhelming. We're talking about flat galaxy rotation curves, gravitational lensing, the dynamics of galaxy clusters, the cosmic microwave background, and the massive filamentary structure of the cosmic web itself. Standard physics has rigorously measured this missing gravity across multiple, completely independent domains. The empirical triumphs of modern astronomy are undeniable here. We've mapped the effects of this invisible weight with staggering precision. But the problem is not that the evidence is weak. The problem is that the source remains hidden. We have a universe that acts heavy, but we simply cannot locate the stones in its pockets. Okay, let's quickly dive into the vault and contextualize case 04. As you can see, we've looked at the lithium problem, the Hubble tension, and the cosmological constant. Today's focus is on gravitational structure and dark matter. To be clear, modern physics is not broken, but it does have these deep stress fractures. The dominant, unquestioned consensus for generations has been that dark matter just has to be a real, non-luminous physical particle. And the global effort to find it, it's been nothing short of magnificent. We're talking billions of dollars, and the absolute finest minds in physics building ultra-shielded cryogenic detectors deep underground to catch a solitary, weakly interacting massive particle. They've smashed atoms at near-light speed in massive colliders. They've deployed satellites scanning the void for anomalous gamma-ray decays. This is serious, rigorous, flawlessly executed science. We have to pay profound respects to that academic pursuit. It's a monumental human endeavor. The search has not failed because it was foolish. It remains unfinished because the universe has not confessed. But, when a search goes on for half a century without catching its prey, science naturally requires us to occasionally step back and ask if we're shining our flashlight in the right direction. And this brilliantly illustrates the core conceptual shift for today's explainer. Standard cosmology interprets the missing gravity as matter hiding in the dark. But what if we look at this through the lens of general emergence mechanics, or GEM? GEM asks a fundamentally different question. Does all this missing gravitational influence actually have to be missing particles? Or could it be geometry carrying weight? So what does that actually mean? Well, in the GEM framework, gravity isn't just an attractive force between objects. It's interpreted as the behavior of depth gradients in a coherence field. Matter is just highly localized curvature. Mass is the structure that alters the geometry around it. Under this lens, a galaxy isn't just a collection of luminous stars sitting passively in an empty void. A galaxy is a massive coherence basin in the very structure of space. The crucial point is this: the visible matter, the shining stars, the glowing gas, might only be the luminous expression of the very bottom of that basin. The visible stars trace just a fraction of the total structure. But the gravitational behavior? That traces the full depth of the geometry. Maybe the universe isn't missing stuff at all. Maybe we're just missing the true depth of its geometric structure. I really want you to sit with that idea for a second. What we call dark matter may be the field remembering depth beyond the visible matter. That is a profound reimagining of the cosmos.
It suggests that the gravitational effects we're observing arise from how the underlying field carries structural depth, and not exclusively from invisible clouds of ghostly particles.
Let's apply this to one of our absolute strongest pieces of evidence: gravitational lensing. Standard physics uses lensing to map where invisible dark matter particles must be located based on how light bends. But in GEM, lensing is framed as the geometry of space speaking to us directly. Light doesn't care about what is shining. Light strictly follows the curvature of space.
And that leads us to a vital distinction. Lensing does not reveal what shines. It reveals what bends the geometry. If a galaxy is a deep coherence basin, the light from distant stars is simply riding the contours of that geometric basin. GEM expands our interpretation. It offers a framework where curvature exists as a fundamental property of the field's depth, entirely independent of luminous matter. Now, a quick note of scientific caution here. We must maintain strict impartiality. GEM is not claiming to have categorically disproven particle dark matter. Dark matter particles absolutely may exist, and the evidence for extragravitational influence remains 100% real. We aren't rejecting standard models. Instead, Jen is stepping back and asking, is our interpretation of that evidence simply too narrow? What fundamentally carries gravitational depth? In these case files, we're operating strictly as forensic investigators. The vault does not ask for belief. It asks what the geometry is telling us. We are neutrally evaluating whether a subtle shift in perspective, from invisible particles to invisible field depth, might finally crack open a 50-year-old cold case. So let's see how this builds into actionable science. Because look, a beautiful philosophical idea is totally useless if it can't be tested against reality. For a GEM treatment to be taken seriously, it must make direct contact with rigorous observations. It has to explain galaxy rotation curves, cluster dynamics, the cosmic web, and show explicitly where a depth gradient interpretation differs mathematically from standard particle halo models. It all comes down to a really simple principle. A new picture is only useful if it tells us where to look next. The true test of the GEM hypothesis won't just be explaining what we already see. It will be predicting novel structural correlations in baryonic matter that standard particle models just don't anticipate. That is how real science moves forward. As we close out this file, we return to the central anomaly. Dark matter is not a fantasy. The gravitational tension holding our universe together is overwhelmingly real, measurable, and verified. But the true nature of what carries that gravity remains completely unknown. Perhaps we've spent half a century looking for a substance when we should have been mapping a structure. Dark matter may not be matter hiding in the dark. It may be geometry carrying weight. I'll leave you with this final provocative thought to turn over in your mind. Look at the data. Look at the immense scale of the cosmos and ask yourself, is dark matter invisible matter? Or is it visible gravity emerging from invisible geometry? Keep that question with you, because how we answer it might just rewrite our entire understanding of the universe. Thanks for joining me for this explainer, and keep your focus on the data.